I have three pH problems that I want to work for you. So the first one reads like this: calculate the pH and POH of a 0.025 molar solution of HBr. Now the first thing you got to remember is that you want to make sure, or you need to determine what kind of acid or base it is that you're talking about. HBr is a strong acid. Okay, so right off the top, that's the first thing that I think about. It's going to be strong, and so the ionization of hydrobromic acid is going to be real simple. 100%, it's going to just go to that. All right? So now, going back to what I can do with the strong acid, if I have 0.025, well, let's write that right. Just mess that up. Do it again. If I have 0.025 molar hydrobromic acid, it's a strong acid, every bit of it's going to break up. I'm going to have 0.025 molar of the hydrogen ions. So all I need to do to figure out the pH is take the negative log of 0.025, and if I do that, negative log 0.025, I end up with a pH which is going to equal the pH, and so the pH is going to equal 1.6. If I'm looking for the POH, the POH will be equal to 14 minus 1.6, and so the POH is going to be 12.4. Oops. Alright? Okay, so that was a strong. Alright, next one. This one. This time you read it, and you go, okay, blah, 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 blah. And then I end up with HF. HF, well, it's not one of the 6 strong acids, plus the fact that I have a Ka given to you right here. That tells you that it's going to be a weak acid. So since it's a weak acid, the calculations are a little bit more involved, because it is in equilibrium. So it still is going to break up, forming a hydrogen ion in solution, but the difference now is that this is 0.0056, this becomes X, and this becomes X. I'm going to use the equilibrium constant right there to tell me how much X there is. So I'll set it up this way: X times X, which is coming from the mass action expression, over 0.0056 is going to equal 3.5 times 10 to the negative 4. So you really see what the significance of having that equilibrium constant, because this is going to tell me how strong this acid, or what the pH of this acid is going to be. So it's going to be 0.0056 times 3.5 to the negative 4th. Okay, so I'll kind of move up over here. So X squared then is going to be equal 1.96 times 10 to the minus 6th. Right, so X then is going to be equal to the square root of that, 1.96 times 10 to the minus 6th. So I'll take the square root of that, and I find that X becomes equal to 0.0014. Now this is one where X probably would make a significant difference in my original amount, but I'm going to stick to my guns and tell you guys just to ignore that. So now, taking the negative log, the minus log of the hydrogen ion concentration, which is what I just solved for with X, that'll be the negative log of 0.0014. Okay, so negative log of that gives me a pH equal to 2.9. Subtract that from 14. POH then, do that in red. The POH then is going to be equal to 11.1. Alright? Try those. Okay, last but not least, I got to calculate the pH of a point and POH of a 0.026 molar solution of strontium hydroxide. Alright, so again, what is it that I got? Well, there's no Ka, there's no Kb, there's nothing, but I do know that that's going to be a strong base this time. So if I take strontium hydroxide and I break it up, I'll get a strontium ion plus 2 hydroxide ions. Okay? So that's kind of the little trick on this one. Because of that 2 right there, I'm going to get 2 hydroxides. So, if I have 0.026 molar of this, it's going to be, according to the mole ratio, that 2 right there says I'll have twice as much. So 0.026 times 2 is going to be 0.052 molar of the hydroxide ion concentration. So now what I have, so you got to be careful because it's a base that I'm talking about. So the OH minus concentration is going to be 0.025 molar. Now if I take the negative log of that, I'm not going to get the pH. I'm going to get the POH directly because that's the concentration that I was given in the problem, or that I'm talking about a weak base or a strong base at this point. So, okay, get a negative log of 0.052. This then is equal to the POH, which is going to be equal to 1.3. I subtract 14. I subtract that from 14. And that's going to give me a pH equal to 12.7. And yeah, the pH should be on the basic side, which it is, because I got a whole slug of base that I threw in there. Alright? Let's see. Let me just talk a little bit about going backwards and forwards. So, here we have a, let's say you're given a POH equal to 6.32. Alright? Now hopefully, by this point, pH is pretty automatic. I'm going to subtract the POH from 14. So pH is going to be equal to 14 minus the POH, which is 6.32. And what I get for pH then, 14 minus 6.32, tells me that the pH is going to be 7.68. Alright? Now, if I want to figure out what the hydrogen ion concentration is and what the hydroxide ion concentration is, the easiest way to do that is for the hydrogen ion, take the pH, alright, so the hydrogen ion concentration now is going to equal 10 raised to the negative, and you got to remember to put that negative, 7.68. Alright? So on your calculator, that's the steps you're going to go to. You're going to say, okay, second, and it's behind the log, it's the second function to the log on your calculator, 10, raise it, change it, and get the negative in there, 7.68, go enter, and this turns out to be 2.09 times 10 to the minus 8th molar. So try that. So now if I want to figure out what the hydroxide ion concentration is, this right here, okay, the hydroxide ion concentration is going to be equal to 10 raised to the negative 6.32. When I do that, okay, second log negative 6.32, I end up with 4.7, close enough, 79 times 10 to the minus 7th molar. Alright? And one thing you should sort of see is if I multiply these two together, if I multiply this times this, okay, you know what I'm going to get? I'm going to get something on the order of 1 times 10 to the negative 14th. Alright? So try those.